everyone, this is Rashekar from Saimedha Coaching Institute. This session is especially for graduates, BE, BTech students. Generally, for BE, BTech, electrical students, we have many opportunities. In that first one, gate examination. Then after PSUs, public sector units. Then after like a state level examinations. State level nothing but like a GENCO, Transco, DISCOMs, distribution companies, and also like a assistant executive engineers in irrigation departments, and also HMWS, like that, state level examinations for electrical students. First, you have to concentrate on gate. If you concentrate on gate, it will useful for all PSUs through the gate and without gate, like a bulk or NJC. Like a some PSUs, public sector units, separately conducting the examination. Of course, some public sector units just follow the gate examination ranks. And then after state level examinations like a GENCO, Transco, DISCOMs. Of course, the syllabus for this GENCO, Transco and DISCOMs is 100% similar to this one, except arithmetic and reasoning in Telangana. And in Andhra Pradesh, of course, they are in that syllabus, arithmetic reasoning also is there. A few electrical, like a utilization also is there, part of the syllabus. But in TS, GENCO, Transco and DISCOM syllabus, 100% similar to gate examination, except arithmetic and reasoning and English. Generally, in this GENCO, Transco and DISCOMs, mathematics, signals and systems, and what is that? Magnetic fields. This is also included already 2 years, 3 years back. Yes or no? Yes or no? So we have to follow the syllabus of GATE even for GENCO, Transco and DISCOMs in Telangana. But in Andhra Pradesh, of course, the examination is as usual. There is no any changes. Previously the syllabus and now the syllabus mostly same. It is same going on. But in Telangana, it is changed to GATE examination. Thereafter, assistant executive engineers and HMWS, these question levels are somewhat less than GATE. Yes or no, guys? Right? So, for electrical engineers, after BE BTech, many opportunities are there. Many opportunities. Right? So, all the opportunities are only one syllabus for all the opportunities. Mostly 90% of syllabus is same, which is GATE syllabus. If you prepare for GATE, it will useful for all these GENCO, Transco, AEE, PSUs, everything. Right? So please concentrate on your GATE examination. Who are already applied, who are awaiting for GATE examination, prepare well, and who are now ongoing batch, BTech ongoing batch, they also try to prepare now, at least before 1 year or 2 years of examination. Then only you will get a good rank. Okay, right. So just this is about GATE. Actually, you know everything in GATE. We have 100 marks. In this mathematics and arithmetical reasoning and our core syllabus, everything you know that. Okay, now just I came here to take one concept, how The examiner will ask the questions on that concept. Let's go for what is that our syllabus. Now I am going to explain you a small concept in transformers. Transformers. In that I am going to explain you a three-phase transformers, a small concept. Regularly they are asking in all examinations some questions. Regularly asking in all examinations. Okay, let's go for three-phase transformers. Okay, before that, everyone try to get a good rank in GATE, then your life is 100% successful. If you got a good rank in GATE, just that is your aim. Who are completed your BTech, who are ongoing batch, just what is your aim? You have to get single digit or at least two digit rank in your GATE examination. It will change your life. Right, sir. So let's go for a syllabus. Our topic, three-phase transformers. They are asking simple questions on three-phase transformers. Let's see some concepts. Let's see some concepts. Okay. Is it okay, guys? Now it is clear. Is it clear? Video and audio, everything is clear. Okay, guys. Right? Let's see. So generally we have a different types of three-phase transformers. Three-phase transformers are delta delta, star star, delta star, and star delta. Like that, we have different types of three-phase transformers. Other than this, we have open delta. Open delta also a three-phase transformer. One of the configuration. Of course, square connection in this, and of course, zigzag connections. Zigzag connections. Zigzag connections nothing but delta zigzag star and star zigzag star. Like that we have a zigzag connections also. Right? We have a different types of three-phase transformers. Now I am going to explain some topics. I think you have many doubts in these three-phase transformers. What are the current ratios? What are the voltage ratios? What is line turns ratio? What is phase turns ratio? What is phase voltage ratio? What is line voltage ratio? What is transformation ratio? Generally, in our question, the voltages given is that is the line voltages or phase voltages. For example, one transformer connection shifted from delta delta to delta star. Then what about power? What about voltage? What about current? These are the questions of regularly asking in every competitive examination based on this. Actually, based on this concept, 100% question in every examination. What we discussed here. Okay, so listen carefully. Listen carefully. So, generally, for all these configurations, first of all, the phase turns ratio is common. Phase turns ratio is always common. Generally, it is taken as x is to 1. The phase turns ratio is common for all these configurations. It is taken as x is to 1. For example, now I am going to calculate line turns ratio. What I am going to calculate now? What is the line turns ratio for delta delta, star star, delta star, and star delta? What is the line turns ratio? Can you tell me, sir? What are the line turns ratios here? Can you tell me? Give me the answers in comment. I am seeing your comments. Okay? Tell me. What are the line turns ratios for these four? First of all, for example, delta delta line turns ratio. Line turns ratio. Line turns ratio, nothing but like a line voltages ratio because number of turns gives the voltage. What is the line voltage for delta? The line voltage for delta is equals to phase voltage as it is. Next, what is the line voltage for secondary? Secondary also delta. Here also line voltage is equals to phase voltage, but with turns ratio x, we are taking turns ratio x. Then the ratio of these two, phase gets cancelled. Then the phase turns ratio x is to 1 as well as line turns ratio for delta also x is to 1. The line turns ratio and phase turns ratio both are same for delta. Right? And next one, what is the line turns ratio for star? For star, the line turns ratio is that, calculate here for star. Okay, for star, line voltage is equals to root 3 times of phase voltage. And even in secondary also star, so line voltage is equals to root 3 times of phase voltage upon, for example, turns ratio x. So again these two gets cancelled out. Again the ratio is x is to 1. The line turns ratio for star also x is to 1 same. So what we observed here, the line turns ratio and the phase turns ratio same for delta and star. Delta and star. The line turns ratio and phase turns ratios are same. Next one, for delta star, what is the line turns ratio? Delta star, let's calculate this one. Similarly, for delta star, for delta, line voltage is equals to phase voltage. For star, line voltage is equals to root 3 times of phase voltage upon ratio x. So phase voltage gets cancelled. So the line turns ratio for delta star is x is to root 3. This is what the line turns ratio for delta star. Now can you tell me what is the star delta line turns ratio? For star delta, the line turns ratio is that for star, line voltage is equals to root 3 times of phase voltage. And for delta, line voltage is equals to phase voltage upon x. Phase voltage gets cancelled. Okay? Phase voltage gets cancelled. Okay? Is it okay, guys? Right? So, line turns ratio. Now, these two get cancelled. Then what is the answer? Root 3x is to 1. So x is to 1 by root 3. These are the line turns ratios of delta star delta. Based on this, we have to conclude some points. What are those points here actually? I said you line turns ratios and phase turns ratios for delta and delta star. See here, just remove this. See here x is to 1, x is to root 3, x is to 1 by root 3. For same turns ratio, for same phase turns ratio, the line turns ratios are like this. For example, its output is 1 nothing but, for example, this is 100%. And here also 1 nothing but 100% we are taking. Here root 3 nothing but how much it is? 173.2%. Here 1 by root 3 nothing but 57.7%. Nothing but for same phase turns, for same number of phase turns, the output voltage for delta star is 173%. The output voltage for delta is only 57.7%. Now tell me, which is most economical? Delta star is most economical, and star delta is least economical, because for same number of phase turns, what happens, sir? For same number of phase turns, here, for same number of questions, the voltage is less here, but here the voltage is more. That's why this is most economical, this is least economical. As well as out of these four, which is used for step up applications? Can you tell me? Which is used for step up applications? Simply, this gives the more voltage, right, on the secondary side. That's why the delta star used for step up applications, delta star used for step up applications, and star delta used for step down applications. Star delta used for step down applications. This is simply a very important question, sir, which is used for step up and which is used for step down, and why? Because like that. And next one, they will ask you a question for distribution transformers, which type of configuration is preferable? Can you tell me which type of configuration is preferable? Delta star or star delta or delta delta or star star, like that. Generally, for distribution transformers, we have to use delta star with neutral grounding. Here, the secondary side, it should be a neutral grounding in order to reduce the short circuit, in order to avoid the fault current to ground. For that reason, we are using delta star with neutral grounding. But here, distribution transformer is the step-up transformer or step-down transformer? Distribution transformer is the step-down transformer. Actually, in step-down transformer, we have to use the star delta. But in star delta, there is no neutral point on the secondary. That's why, due to this reason, we are not using this one. We want this neutral grounding. That's why on the secondary side, it must and should be a star connection. That's why. Okay, no. Distribution transformers are step down transformers, of course. So for distribution transformers, we have to use delta star with neutral grounding. Because of neutral grounding, we have to use delta star here. But actually, the delta star 100% preferable for step up only. The star delta 100% preferable for step down only. This is 100% correct. Okay. This is 100% correct. Okay. Right? Everyone. Mammo, it is 100% correct. No doubt. Right? Next one. Let's go for delta and star. Once, let's go for delta and star. Okay, so let's see here. Delta configuration and star configuration. Generally, in delta, the phase voltage exactly equals to line voltage. The phase voltage exactly equals to line voltage. And here, the phase voltage is equals to root 3 times of, the phase voltage is equals to, tell me how much? Line voltage upon root 3. We know that generally in star phase voltage is equals to VL by root 3. In delta phase voltage is equals to line voltage. Okay. So tell me, in which more number of phase turns we required, in which less number of phase turns we required? Can you tell me? In which more number of phase turns we required, in which less number of phase turns required for same voltage rating? For same line voltage rating, For same line voltage rating, here phase voltage is equals to line voltage, but here phase voltage is equals to line voltage by root 3. For example, my line voltage is equals to 100 volts. Here the phase voltage is equals to 100 volts, but here the phase voltage is equals to 100 by root 3, which is equals to 57.7 volts only. Nothing but here, less number of phase turns, here more number of phase turns, right? Less number of phase turns, here more number of phase turns. As usually, here insulation requirement is also less. Here insulation requirement is more. Because of high phase voltage, we have to take more phase voltage. Because of less phase voltage, just less insulation is required. So for same voltages, here more number of turns, more insulation. For same line voltages, here less number of turns and less insulation. Now tell me, which is used for high voltage applications? Which is used for high voltage applications? Actually, due to less number of turns, due to less insulation requirement, the star used for high voltage applications. Delta used for low voltage applications. I think you have a doubt, sir, how it is possible? Actually, here we have a maximum phase voltage, here we have a less phase voltage. That's why this is used for low voltage, this is used for high voltage. That concept is 100% wrong. For example, let's see here. I will give you one example for this. Just for clarity, I am giving you one example. For line voltage of 100 volts, here also line voltage of 100 volts, here I required, for example, 100 kgs of copper, 100 kgs of insulation, for example. Okay, just listen what I am saying first of all. For example, line voltage of 100 volts, here I required 100 kgs of copper and 100 kgs of insulation. How much here I required insulation as well as copper? Here I required no copper. Over here more number of tons nothing but copper, right? Less number of tons, nothing but copper, right? Okay, copper means number of tons. Let's see here. Here, for same voltages, we required less insulation, less number of tons, less copper, less insulation. Just 58 kgs of insulation and 58 kgs of copper. Just 58 kgs of insulation, just 58 kgs of copper. For 100 volts, For example, listen carefully what I am saying here. For example, I am using 100 kgs of copper, 100 kgs of insulation in star. For example, I am using now 100 kgs of insulation, 100 kgs of copper. Then is this used for 50 volts or 150 volts range? We can use for greater than 100 volts range, because here for 100 volts we are using 50 kgs, 58 kgs. Then if you used here 100 kgs of insulation, we can increase this voltage up to 150 volts or 130 volts or 120 volts, whatever it may be. But we can improve that. We can increase this because insulation increases, right? So copper increases, right? So we can increase this up to, it may be a some change, right? That's why here for same 100 kgs of insulation, for same 100 kgs of copper, we can use up to 150 volts, but here we can use up to only 100 volts. So now tell me, for same copper, for same insulation, for same number of tons, which is used for high voltage applications? Star star used for 150 volts, but delta delta only used for 100 volts. Okay, that's why the star star used for high voltage applications and delta delta used for low voltage applications. Okay, low voltage applications, right? Okay, okay, I will tell you, sir. I will tell you, sir. Okay, so this is the concept actually very important. Generally, people getting confused here. That's why just I want to tell you, just who are not understood, just after completion of this class, once again go through the class. You will get an idea. Okay, so whatever, just leave it. Next class, you will get a clarity about this. So whatever, delta delta used for low voltage applications, star star used for high voltage applications. Right? Next, let's go for high voltage, low voltage completed. Let's go for current, current for delta delta and star star. Here in delta delta, the phase currents is equals to, okay sir, the phase currents is equals to how much? Line current by root 3. In star star, phase currents is equals to line currents. Phase currents is equals to line currents by root 3, but here phase currents is equals to line currents in star star. We know this is the simple thing actually, right? So here for same phase current, the line current, see, line currents are important here. Okay, so tell me in which the conductor size is more. In which the conductor size is more. Now tell me, according to current, generally the conductor should carry the current, right? The current carrying capacity is based on our conductor size, right? Here, phase current is equals to IL by root 3, but here phase current is equal to IL. For example, my line current is equal to 10 ampere, then here phase current also 10 ampere. For example, say my line current is equal to 10 ampere, 10 by root 3, so this is the 5.77 amperes. Here less current, here more current. Here conductor size less. Here conductor size more. Conductor size more. Nothing but here less copper required. Here more copper required. More copper required because of conductor size. Here conductor size is less. So, from this analysis, which is used for high current applications, which is used for low current applications, in which the requirement is less, that will use it for high current applications, and in which requirement is more, that will use it for low current applications. If the requirement is more, we have to use for less. If the requirement is less, nothing but we can use it for high current applications. So this is used for high current applications and this is used for low current applications. Okay guys? Okay guys? So finally, what is the conclusion from this? What are the conclusions from this up to now? The delta delta used for high current low voltage applications, star star used for high voltage low current applications, delta star used for step up applications, star delta used for step down applications. Among all these, this is most economical, this is least economical. You have to remember all these points. Actually these are the theory concepts, right? Generally these are the questions for all competitive examinations except GATE, but in GATE 90% of questions are only problematic. Let's go for some problematic view of these four configurations, right sir? Let's go for that. Here for example, I have a transformer of 11 kV by 33 kV. This is my three-phase transformer. What is this? This is my three-phase transformer. Can you tell me what is this ratio? What is this ratio? Generally, what they mentioned in the nameplate details, what they mentioned in our question, those are the line voltages only. Exactly, those are the line voltages only. And this ratio is called line voltage ratio. This ratio is called line voltage ratio. What it is called? Line voltage ratio only. So line voltage ratio nothing but line voltage of the primary by line voltage of the secondary. That's it. For example, phase voltage ratio nothing but phase voltage of the primary by phase voltage of the secondary. That's it. But in our question and nameplate details, what they given, that is the line voltage ratio only. Our answer also should be in line voltage ratios only. Next one. What is transformation ratio then? Transformation ratio. Transformation ratio nothing but, can you tell me? Transformation ratio K is equals to, what is that? The phase voltage of the secondary to the phase voltage of the primary. You know already, but just for a clarity, I am giving you few points. So what they given, that is the line voltage ratio. If you want phase voltage ratio, V1 phase by V2 phase. If you want transformation ratio is equals to, what is that? Phase voltage of the secondary to the phase voltage of the primary. Okay guys. For example, line turns ratio or phase turns ratio, they will give you phase turns ratio. Phase turns ratio nothing but we have to take N1 by N2, that's it. Phase turns ratio nothing but, generally phase turns ratio is equals to N1 by N2. Remember these points. Based on this, generally they will ask you questions. Whatever they asked in your examination, you have to use at least one of these four. By using these concepts, you can calculate. But these are the basics for any question. What I said, that any question, these are the basics. Right, sir. Next one. Let's go for next concept. You know already these things, but just I repeated here. Let's go for next one. For example, I have delta star three-phase transformer. In delta star three-phase transformer, this is the phase voltage. Of course, this is also called line voltage. And this is also called phase voltage. Here the current is line current, and here the current is phase current. Of course, here the current is line current. As usually, this is the phase current. Of course, and here the voltage is called line voltage. Here the voltage is called phase voltage. We know all these things already. For example, here the transformation ratio is K. I am checking here. So now tell me, what is the relation between voltages and currents here? You have to calculate. For example, they will ask you a question. The line voltage of delta is 100 volts. Then phase voltage of star. Like that they will give you a question. Can you calculate and give me the answer fast? Tell me. Here the given line voltage of delta is 100 volts. in delta, line voltage is equals to 100 volts. Now they asked that in star, phase voltage is equals to how much? In our delta star configuration, for example, the transformation ratio they given K, that's it. So how we can calculate? How we can calculate? So tell me the answer. Simply, first we have to convert into phase voltage. What is the phase voltage of delta? The phase voltage of delta is equals to 100 volts because in delta phase voltage is equals to line voltage. So the phase voltage of delta is equals to 100 volts. Now we have to calculate phase voltage of star. How we can calculate phase voltage of star? This is a delta star transformer. The transformation ratio K is equals to the phase voltage of star by phase voltage of delta. That's it. I want the phase voltage of star. So this they given K only. K is equals to phase voltage of star upon delta of the phase voltage. The phase voltage of delta is the 100. Therefore, the phase voltage of star is equals to 100K. The phase voltage of star is equals to 100K. Like that, they will ask you question. Okay, so based on this, there is a 100% question in every examination. For example, let's go for next question. For same configuration, next question clearly. My transformation ratio is equals to 3. My transformation ratio is equals to 3. They given. And primary line current 10 amperes, 30 amperes. Primary line current 30 amperes. Then find secondary line current. Like that, they will give you options. So tell me what is the answer for this question? Do it and give me the answer. Do it and give me the answer fast. Come on, sir. Let's see. They given primary line current. Primary line current is equals to 30 amperes. And they given transformation ratio K is equals to 3. Now they want secondary line current. Like this, they given. So calculated, the primary line current is equal to 30 amperes. Then primary phase current is equals to primary nothing but delta. In delta, phase current is equals to line current by root 3. In the delta, phase current is equals to line current by root 3. This is what my primary phase current. Then what is the secondary phase current? How we can calculate? Very simple. The transformation ratio K is equals to I1 phase by I2 phase. Don't take I2 by I1. Here transformation ratio K is equals to I1 by I2. I want I2. So I2 phase is equals to I1 phase by K. What is I1 phase? I1 phase is equals to 30 by root 3 into K. What is K here? K is equals to 3. This is what the I2 phase value. If this is I2 phase value, tell me, this is I2 phase value, then what is I line to, what is the secondary line current? The secondary line current, secondary nothing but star, in star line current is equals to root 3 times of phase current. So line current is equals to root 3 of phase current. Phase current nothing but 30 by root 3 into 3. Root 3 gets cancelled. Then this is the 10 amperes. then this is the 10 amperes. Is this is the 10 or 20? Hanif, calculate it. How much it is? So this is the question. What is that? Here the line current is 30 amperes. Here the line current is 10 amperes. Of course, you can find directly also. No need of all these things. But the concept is important. Just for concept, I came here through this one. But you can find, if you know this one, you can find this one easily. Of course, here one problem is there. Don't take the transformation ratio is the ratio between phase currents, not for line currents. If you take as usually, it will get wrong answer for other configurations. Of course, you have an idea, sir, there is 30, 30 by 3 is equals to 10. But the transformation ratio is belongs to for phase currents. That is the phase current ratio, not for line currents ratios. Right, sir? Right, sir? Very good. So this is simply what the current and voltage ratios they are asking, which is very important for every competitive examination. In every competitive examination, they are asking the questions. Right? Let's go for next concept. Let's go for next concept. For example, I have a delta star transformer, some 10 kVA or 15 kVA. For example, 11 kV by 33 kV. This is the 10 kVA, 11 kV by 33 kV. This transformer rewounded as star-star transformer. Rewounded as star-star transformer. Then what is the kVA rating and what is the voltage ratings for this star-star? Like that they are asking the questions. Okay, are you getting or not? What I am saying that actually my three-phase transformer is delta star and its kVA rating given and its voltage rating also given. Now this three-phase transformer reconnected as star-star. Now I want the kVA rating as well as voltage ratings. This is the question. Can you tell me what is the answer for this question? Can you tell me what is the answer for this question? Come on, sir, do it. Come on, sir, do it. Very simple question. Do it fast. Anyone get the answer? Let's see here. Let's see here. Generally, whatever the transformer configuration, the kVA rating is constant. There is no change in kVA rating. Even this is transferred into delta delta, even this is rewounded for star delta, whatever the configuration, the kVA rating is constant, no change of power rating. First one. Next second one, for any configuration, I said you already, phase turns ratio. Phase turns ratio is constant, that is x is to 1. Always the phase turns ratio constant for all the configuration. We have to use this point here. Nothing but how we can use this point here. Here, these are the line voltages of delta and star. Simply, these are the line voltages of delta and star. I want the phase voltages of same. What is the phase voltage of delta? Same, 11 kV only, because phase voltage is equals to line voltage. Then what is the phase voltage of star? The phase voltage of star is equals to 33 upon root 3, because phase voltage is equals to line voltage by root 3. This is the phase voltages of delta star. These phase voltages are same for any configuration. If you rewound it, the phase voltages are same, whatever you configured. If you want to rewound for star star, delta delta, star delta, whatever it may be, The phase voltages are constant for any configuration. So, but our answer should be in terms of line voltages. Then, what is the line voltage for these? What are the line voltages for these? So, calculated the line voltages for those. Very simple. In star star, the line voltage is equals to root 3 times of phase voltage. So, root 3 times of phase voltage, root 3 times of phase voltage, and here also root 3 times, nothing but 33 only. This is what the transformer voltage rating for star star. If you want to convert into delta delta, then this is the line voltages or phase voltages. These are the phase voltages. Of course, in delta delta, the phase voltage is equals to line voltage. This is same. This is the actual the transformer voltage rating. And what about this? Here also, this is the star. So for star, the line voltage is equals to root 3 times of phase voltage. And for delta, line voltage is equals to phase voltage. Line voltage is equals to phase voltage as usually. As usually, if you cancel, we can get cancelled out, of course. So these are the questions they are asking continuously in our competitive examinations. Regularly, these are the questions they are asking, right? Okay, so these are the concepts. Based on this, how they will ask us the questions in our competitive examinations, like a GATE or Genco Transco or IES. Let's go few problems. You have to do those problems. Okay, I will not tell you. You have to done. You have to do. Okay, so let's go for problems. నాకు అది కావాలి. Okay, guys, let's go for problem. Let's go for problem. Right. Let's see here. Do this problem and give me the answer first. Which option is correct? First, go through the question here. First, go through the question. And 11 kV by, what is this? And 11 kV by 400 volts, 1000 kVA, star transformer is reconnected as delta star transformer. This star reconnected as delta star with the high voltage side connected to delta. This 11 kV is connected to delta side. They mentioned already, because what we discussed, generally high voltage should be connected to star, we discussed earlier, but he given clarity here in this question. High voltage side connected in delta. They mentioned already, don't confuse here. The rating of new connection will be, what is the rating of new connection? This is the question, what we discussed earlier. So tell me, what is the answer? Option A, B, C, D. Among this, which is the correct answer? You have to do. I won't give you options. I won't give you calculations. You have to do the answer. So first we have to eliminate the options. What I said you, the power rating of the star is 1000 kVA. The power rating is same for all the configurations. Whatever the configuration, this answer should be 1000 kVA only. So option A is the wrong answer and option D also wrong answer, because here the power rating is, option A is correct only. Option A is correct only, right? Option B is the wrong answer and option D is the wrong answer. Option B, what they given? 173 kVA. In option D, they given 1000 by root 3 kVA. These are the wrong answers. So the answer may be option A or option C. So which is correct answer? What they given? For star star, the voltage rating is 11 kV upon 400 volts. This is what? Line turns ratio. Line voltage ratio or phase voltage ratio? This is the line voltage ratio. So we have to convert into phase voltages. The phase voltage for star is equals to line voltage by root 3, and the phase voltage for 400 also 400 by root 3 volts. This is what the phase voltages for star star. Then these phase voltages are same for, these phase voltages are even same for delta star also. These are the phase voltages. What I said you, the phase voltages are same for all the configurations if you want to reconnect. So now tell me, what is the line voltage for this? Here delta is there. In delta, line voltage is equals to phase voltage. So the line voltage and phase voltages are same. 11 by root 3 kV for delta side. For star, actually this is the phase voltage. This is the phase voltage. Now we have to convert into line voltage. For star, line voltage is equals to root 3 times of phase voltage. Root 3 times of phase voltage gives us root 3 into 400 by root 3. Root 3 cancelled out. So 400 volts. So this is what the transformer voltage ratings for delta star. So see which is correct answer. 11 by root 3 and 400. 11 into root 3 by 400. Which is correct answer? Option A is 100% correct answers. Very good. Wow. Who are done the question? Very good. Right? So like that they will ask you questions in our competitive examination. This is previous engineering services examination question. Like a questions many are there. Right. Let's go for second question. Let's go for second question. Okay. Let's see here. Can you do this problem? Can you do this problem? Do and give me the answer fast. Come on, sir. Come on, sir. First see the question. Three single phase transformers are connected in star delta. Like this, star delta. Three single phase transformers are connected in star delta to form a three phase transformer bank. Because three phase transformers, we can use a single three phase transformer or three single phase transformer combinedly connected as a three phase transformer bank. Now this is the second category. In this, as shown in figure, it is used to step down the voltage of, this is used to step down what we discussed earlier actually. Okay? Who have the doubts? It is cleared. Right. So this is used to step down the voltage of three phase 6600 volts transformer line. So now he want to step down the voltage from 6600 volts, from 6600 line volts to some other volts. So from 6600 volts transformer line. If the primary line current is 10 amperes, here the primary line current is 10 amperes. This is the line current, remember this. Next one, primary line current is 10 amperes and turns ratio is 12. What they given, this is not a transformation ratio, this is the turns ratio. 12 is to 1 in the diagram mentioned clearly. This is the 12, this is the 1, because they said already this is a step down application. Okay, 12 is to 1. Then the output kVA will be very interesting question. Now they asked the output kVA. We discussed just for voltage and current, but now they are asking output kVA. Right, sir. Let's see here. Let's see here. Once observe here. They given this is the line voltage of 6600 volts. Then what is the phase voltage here? What is the phase voltage here? The phase voltage is that this is the star, that's why 6600 by root 3. This is what the phase voltage of the primary. This is what the phase voltage of the primary. Right? Next one. Here the line current of the primary is 10 ampere. Then what is the phase current of the primary? The phase current of the primary also 10 ampere because in star line current is equals to phase current. Okay, now I have a phase current of the, what is that? Phase current of the primary. Can you tell me what is the phase current of the secondary? Very simple. They given turns ratio. From the turns ratio, N1 by N2. They given N1 by N2 is equals to 12 is to 1. N1 by N2 is equals to 12 is to 1. But we know that N1 by N2 is equals to I2 by I1. I2 by I1. So I2 is equals to 12 into what is this 10 amperes. 12 into 10 amperes, which is nothing but 120 amperes is the this secondary phase current. If you want that secondary line current is equals to how much? This is a delta, right? In delta, line current is equals to root 3 times of phase current. Root 3 times of phase current. This is my secondary line current. So I want that what is the power output kVA rating. The power K is equals to root 3 VL IL. Root 3 VL IL. So root 3, what is IL? IL is equals to root 3 into 120. What is VL2? What is VL2? We have to calculate VL2 also. So how we can calculate VL2? I know V phase 1. Can you tell me what is V phase 2? Calculate it first. If you know the V phase 2, you can know the VL2 because in delta line voltage is equals to phase voltage. Very simple, right? Tricky question actually, not simple. Okay, so the E2 upon E1 is equals to N2 upon N1. From this, E2 is equals to E1. What is E1? 6600 by root 3. 6600 by root 3 into N2 by N1. What is N2 by N1? N2 by N1. N2 is the 1. N1 is the 12. N1 is the 12. This is what exactly E2. We have to substitute here 6600 upon root 3 into 12. Root 3 into 12. So calculate it. Root 3 gets cancelled. 12 ones, 12 tens are. So what is that? 66. The power rating is equals to 66 into root 3. 66 into root 3 into 1000. 1000 nothing but kVA. 1000 nothing but kilovolt amperes. So 66 multiplied by root 3, you don't have a calci, but we have to do this 66 into root 3. How we can calculate? First come here. So here 66 is there. Is it correct? Option A is wrong. 198 is there. 198. 33.8 is wrong. 38.1 is wrong because 66 into root 3. Now tell me which is correct answer among these. What is 66 twos are? 66 twos are 60, 60, 120, mostly 130 change. Yes or no? 132 if this is the 2, 66 into 2. But here less than 2, nothing but 66 into root 3 value less than 132. Less than 132. This is not correct answer. This is the correct answer. 114.3. 114.3 is 100% correct answer. Generally, you people must do the wrong answer because of lack of knowledge here. What we discussed up to now in our concept, Every point is used here. Once observe what I discussed in the concept. Every point is used in this question. Yes or no, guys? Right? So this is the our second question. Like these questions, this is the previous gate question. Now let's go for next question. Now let's go for next question. This is also previous gate question. Fill in the blank. You have to fill this blank. So do the question. Once you see here, what is the question? First, go through the question. If the primary line voltage rating is 3.3 kV, primary line voltage they given 3.3 kV, which is star side of 25 kVA. This is the star side of 25 kVA. 3.3 kV is the primary line voltage star delta transformer. Right. The per phase turns ratio. The per phase turns ratio. The per phase turns ratio nothing but simply the given turns ratio per phase. That's why N1 by N2 is equals to 5 by 1. That's it. No confusion here. Right, sir. Then the line current rating of the secondary side. They want that line current rating of the secondary side. They given the star and the delta, star and the delta. The turns ratio they given 5:1, turns ratio 5:1, and they given its primary line voltage of 3.3 kV, primary line voltage of 3.3 kV, and its kVA rating 25 kVA, kVA rating 25 kVA, and now they are asking that the line current rating of the secondary, they asked this current I2 line. So can you do and give the answer? Can you do? Can you do? Come on, sir. Come on. Once see here. First of all, the power P is equals to root 3 VLIL because of kVA. This is not kW. Don't take cos pi. So P is equal to root 3 VLIL. What is P? P is equals to 25 kVA root 3 into VL. What is VL? 3.3 kVA. 3.3 kVA multiplied with the IL. So if you calculate this, you can get the line current of the primary. Yes or no? Line current of the primary. Can you tell me what is the line current of my primary? Come on, sir. Calculate it and give the answer. So its value 4.374 amperes. This is what the line current of the primary. Next, what is the line current of the secondary? Before that, we have to calculate phase current. So this is a star, right? In star, line current is equals to phase current. So the phase current of the primary also 4.374 only because of star. Now N1 by N2 is equals to I2 by I1 from this, tell me, from this I2 phase is equals to, calculate it. So N1 is the 5 by 1, I2 we have to calculate, I1 is equals to 4.374. Okay guys, so what is the answer for this I2 phase? Calculate it fast immediately and give the answer. So from this I2 is equals to 21.869 amperes. 21.869 amperes. So this is what phase current of the secondary, not line current. This is not line current. Don't write here this one. What is the line current here? The line current is equals to root 3 times of the phase current because of delta. Root 3 of 21.869 amperes. You have to calculate this one. There is no expectations because there is no options. Why I given this question is that previous question without calculator we can do the answer just by analysis, but here there is no analysis, there is no elimination method. We must use the calci or we have to calculate it. So can you calculate and give the answer? Yeah, its value around 37.87 amperes, 879 amperes. We have to make it up to at least three decimal points, right? This is the our questions. What we discussed the concept, based on that concept, previous PSU question and gate question and ESE question. So, like a questions are repeating in our transformers. This is the best concept to get the marks. So, this is about today's session. So, prepare well. Who are preparing for gate? Just go through total syllabus. Just prepare well, and tomorrow we will meet with another session, like in electrical machines only. Like we have a 4 electrical machines, right? Today I just complete one machine in that in transformer, one concept, a small concept, and tomorrow I will be here with a different concept, like which is very important for us. For more videos, for more updates, download our mobile app Saimedha Gate. Okay? Are you okay? Did you remember our institute? Saimedha. Saimedha Gate is our mobile app. First go to your mobile, what is Google Play Store, download it and see the videos. Many videos are there, like IITians are there, and our chairman Ramana sir also is there. Okay, in next sessions, Ramana sir also will take you classes here. Okay, so like, share, and subscribe our Saimedha YouTube channel, as well as download our Saimedha Gate mobile app. Okay, we'll meet you tomorrow with the next concept. Thank you.